In this video, I will go over the different coordinate systems and their use in GIS. There are two types of grids, Cartesian and spherical. Cartesian grids are more like what I have shown you on this page, and they're based on cubes or rectangular prisms. They have an X and Y axis and sometimes even a Z axis with both negative and positive values. Spherical grids, on the other hand, are based on spheres. They have lines of latitude and longitude, as well as a z-axis. Lines of latitude run parallel to the equator from north to south and are separated at equal distances. Starting at the equator, lines of latitude range from 0 to 90 degrees at the North Pole and 0 to negative 90 degrees at the South Pole. Lines of longitude run perpendicular to the lines of latitude. They are not equally spaced, with the amount of space between them decreasing as they move from the equator until they merge at the poles. Similar to the equator, the prime meridian is located at 0 degrees longitude. Beginning at the prime meridian, lines of longitude range from 0 to 180 degrees east and 0 to negative 180 degrees west. The prime meridian is located in Greenwich in London. You may have heard of GMT, which means Greenwich Mean Time, or Coordinated Universal Time, UTC, which also refers to time in Greenwich. This is because English sailors used Greenwich as a 0-degree median and a constant time for navigation purposes, and because it housed the Royal Observatory. During the late 1800s, England was the world power and had an incredibly strong navy. So the rest of the world adopted their system at the International Meridian Conference in 1884, formally creating the prime meridian. The way I remember the difference between lines of latitude and longitude is that lines of latitude are drawn like you are climbing up and down a ladder. Lines of longitude on a globe just look long. They remind me of how I feel when I'm at the base of a mountain and I see the long journey that I have ahead and need to hike all the way to the top, like the North and South Poles. You may also hear the terms small circle, great circle, and arc. Circles cut the globe into two parts. Think about having a huge beach ball and a hula hoop. The beach ball is magically floating in the air at one location. You can move the hula hoop around the beach ball in a million different ways. Now, imagine that hula hoop has a remote control laser beam that shoots out of it, so now it's more like a laser disc. Now, place the hula hoop around the circle any way you want and turn on the laser. Boom! The beach ball explodes into two perfectly cut pieces. That's what these circles represent, where the beach ball, or globe, is being cut into two parts. Small circles can cut the globe anywhere, in any direction, so long as they split the globe into two parts. Lines of latitude are great examples of small circles. Great circles are circles that cut the globe precisely in half, like the equator, and lines of longitude. They can split the globe in any way they like, so long as they cut the globe directly in half. Arcs are lines, curved or straight, that connect any 2 points. Arcs also refer to the line segments that make up the geographic grid, which is what I'm going to be referring to as arcs in the next slide. Longitude and latitude can be measured in decimal degrees, DD, or degrees, minutes, seconds, DMS. They both represent the same values and can be converted back and forth from one to another. Cartesian coordinates traditionally have the x value followed by the y value, but it's the opposite here. Degrees north and south are first, followed by degrees west and east, and then are potentially followed by a height value. Each number may be followed by a direction, such as north, south, east, or west. If the directions are not included in the number group, make sure you know which hemisphere you're in. Oftentimes, instead of a direction, a negative symbol is used for south or west. If you are given a list of coordinates and they don't have any direction in any of the values that are listed, double check to make sure that they are in the northeast quarter of the Earth. If they are not, change the points to make sure that the points are being displayed correctly. Decimal degrees look like any other number, but they are in groups of 2 or 3 to represent the values in each direction. Coordinates in degrees, minutes, seconds are a bit more complicated and isn't used much anymore because it takes more effort on the part of the computer as well as the user to process. The first number represents the degrees, which is the same number as the number on the left, and in decimal degrees. Then you have minutes represented with a prime symbol, which appears similar to an apostrophe or quotation mark, but it's more straight than curved. Seconds are represented by a double prime symbol. As I said earlier, you can convert back and forth between decimal degrees and degrees, minutes, seconds. I'm not showing you the formulas yet because I think they're easier to understand when you understand the concept first. Arcs, or in this case, each line segment in a geographic grid, can be split into intervals of 1 degree. 1 degree can be split into 60 minutes. Each minute can be split into 60 seconds, just like time. So when you multiply the number of minutes by the number of seconds, you get the total number of seconds in 1 hour, or in this case, in 1 degree. Again, there are 60 seconds in 1 minute. There are 60 minutes in 1 degree, or 1 hour. Therefore, there are 3,600 seconds in 1 degree, or 1 hour. 1 degree equals 60 minutes, which equals 3,600 seconds. When you are converting between the different formats, don't worry about the number of the degrees to the left of the decimal point in decimal degrees, or the total degrees in degrees, minutes, seconds. In decimal degrees, we only need to worry about the number after the decimal point. That number represents the percentage or proportion of a degree that's left over. In degrees, minutes, seconds, we only need to worry about the minutes and seconds. It really helps me to think of this in terms of time instead of degrees of latitude and longitude. If you can, I highly suggest dropping the symbols attached with the numbers from your brain. We only need to worry about converting a percentage or a proportion of 1 degree. If we have 35.5 degrees, that's the same measurement scale as 35.5 hours. 35.5 hours is the same as 35.5 minutes, or 35 minutes and 30 seconds. In order to get a percentage of a total, you can multiply that percentage in decimal form by the total value. 0.5 times 60 is 30, right? So when we're converting decimal degrees to degrees, minutes, seconds, you just multiply the number to the right of the decimal by 60. But more specifically, you multiply the first 2 decimal points to get the number of the total minutes. Then you multiply the third, fourth, and any other decimal point by 3,600, leaving the first 2 decimal places with the value of 0 because they need to be subtracted from the total. That number is your total number of seconds. Done. Converting from degrees, minutes, seconds to decimal degrees is similar, but you divide instead of multiply, and then you add the numbers together to get the total leftover percentage of an hour or a degree. I have 2 calculation examples in the next 2 slides per each. The formulas are at the top of the slide for converting decimal degrees to degrees, minutes, seconds. We are going to use Birchfield Geography Building as an example. Birchfield is located at 35.9566 degrees north and 38.9276 degrees south. Notice the negative sign. Because the number of degrees is the same for both, I just drag those values down to the bottom. Focusing on the example on the left, we multiply 0.95 by 60 minutes to get the total number of minutes, which just so happens to be 57. I drag that number down to the bottom and add the prime symbol after it. I actually used a quotation mark here because trying to find the prime symbol took too long and I just copied and pasted it. Don't judge me. All right, degrees, done. Minutes, done. Now on to seconds. I took the third and fourth decimal places and put them after 0.00 because I already took care of the first two values. 0.0066 times 3,600 is 23.76. So there are 23.76 seconds, and that gets dragged down to the bottom too, to make 35 degrees, 57 minutes, and 23.76 seconds. You should never have degrees with a value that has a decimal in degrees, minutes, seconds, unless you are rounding to a whole number. Any decimal values needs to be converted to minutes. The same is true with seconds, unless you are rounding the total number of minutes. If you are calculating 3 individual values, the only value that should have a decimal point is the amount of seconds. In the second example, I did the same thing. I dragged down the degree values of -83. I multiplied 0.92 by 60 minutes and got 55.2. That 0.2 is no good. It's not a solid minute. I need to turn that percentage of a minute into seconds and then add it to the rest of the number of seconds. 0.2 is the same as 2/10. 2/10 times 60 seconds is 12 seconds. But I still need to calculate the rest of the seconds that were given in the original decimal degree value. So I multiply 0.0076 by 3,600 and I get 27.36. I still have those 12 seconds left over from the minute calculation, so I will add those in and get 39.36 seconds with a total value of -83 degrees, 55 minutes, and 39.36 seconds. Whew. Moving on to the next one. Now, switching back from degrees, minutes, seconds to decimal degrees. Like with the last two examples, I will drag down the whole number of degrees first, starting with the example on the left. We have 35 degrees, 57 minutes, and 23.76 seconds. The 35 is already accounted for, so I'll just move on to calculating the number of minutes as a percentage. In order to do that, I just divide 57 minutes by 60 and get a lovely solid 95%, or 0.95, and then I drag that down to the bottom. In this case, I'm able to just add it into the bottom because it only contains 2 decimal points. All that's left is converting the seconds into a percentage. So I divide 23.76 seconds by 3,600 and get 0.0066. And then I drag that down to the bottom to get 35.9566 degrees. On to the second example. The -83 degrees is already accounted for, so I'll start with the minutes. 55 divided by 60 is 0.9167. However, unlike the first example, we have extra decimal values here, but they're okay because we can just add them together in the end. So then I divided 39.36 by 3,600 and got 0.0101. So if you add those two values together, you get a total value of -83.7276 degrees. Your values may vary slightly depending on what you round to, so keep that in mind. Now that wraps up this video on coordinate systems and math for this week.